Hi, I'm Bob Henry, Product Manager for Epilog Laser. You're joining us today from our global headquarters here in Golden, Colorado. Thanks for taking some time to be with us. Today we're going to talk about flying optic laser system technology. We're going to talk a little bit about materials, about applications. Mostly though, we want to talk about trends in laser system design. With 25 years experience designing and manufacturing laser system, with constantly going out into the marketplace to understand the needs of our customers, we've come up with a new design. We think it's fantastic. It's going to be revolutionary in the marketplace. We call it the Fusion technology. The Fusion laser system we offer in both CO2 format and also fiber format. We'll talk a little bit about the differences in applications and material use with these systems as we go along. But again, thanks for joining us. We're going to spend a little time now up close going over the system, both the mechanical side, the design side. So with that, let's get started. The first thing you'll notice about the Fusion laser systems are the colors. The CO2 products are all branded Epilog blue. You'll also notice the very large viewing window. Our customers love this. They like the ability to see what's going on inside the laser system cabinet during operation. The Fusion laser systems, of course, are yellow in color, but you'll also notice this green Lexan material. This safety glass, safety acrylic, has an impregnated organic dye in it that stops the transmission of this wavelength of light. We're going to spend a little time now in the CO2 laser system. I want to show you design components, things that we've done with this particular line or technology. So with that, let's take a close-up look at the CO2 product. We'll go into some of those details. The first thing I want to talk about with the Fusion laser system is the chassis itself. The chassis is a welded steel construction, 10 times stronger than anything we've manufactured in the past. The chassis serves as the foundation for the system. It provides for really good and very fast marking, engraving, and cutting speeds. Speed is important, but again, quality is the most important thing for our customers, and having a really solid foundation with this chassis is the starting place for that. I also want to point out this large door. We talked about this briefly before. We've got a great viewing window in here. Also, we've got a lighted LED bank in here. This is wonderful for our customers that are maybe working in a darker environment. It provides great illumination inside the laser system. Allows the operator to see what's going on in the laser all the time. This front door is also really nice. There's a couple features I want to point out here. First, it allows for easy access in and out of the laser system. It allows the operator to load parts and unload parts very easily. You'll also notice on the front door we've got a honeycomb grid assembly built into the front door. With this door closed, it provides for laminar airflow throughout the laser system cabinet to the back, to the plenum, where the smoke, the vapors, the particulates are very efficiently removed from the laser. You'll notice when we do some wood engraving and cutting in a little bit, you'll see this airflow, and this design with this honeycomb in here facilitates that. Great setup. The next thing I want to point out with the laser is the table. The table itself has a 32-inch by 20-inch work area. We have other CO2 products that are smaller. We've got a system that's larger as well. This is a great size. We've heard from a lot of people in the marketplace that they want this size. We're happy to deliver that now with the Fusion series laser. The table has a 4 lead screw design. We have 4 lead screws on all 4 corners of the table. They're synchronized to move up and down. I should point out that we've got a 14-inch Z capacity in this machine. That allows our customers to engrave on very tall items. Along with the table, we have the optional vector grid. This vector grid is used for cutting applications. You can also engrave with it, but those customers that are not doing any cutting applications, they can simply not buy this and engrave straight on the engraving table. The vector grid is a wonderful tool, again, used principally for cutting applications. One of the neatest things about the Fusion laser really is the advanced motion control that we've designed into this. Advanced motion control really encompasses a lot of things. It's of course the chassis, the steel, the rigid chassis, provides the foundation. It's the motors. It's the design of all the components in here. It's the firmware. It's the electronics in the system that drive the entire system. The motors that we build into this thing are US manufactured. They carry a 3-year warranty. We've done extensive testing with these and found that they're incredibly robust, and they're maintaining very good operating temperatures as well. In our bench testing that we've done, we've subjected them to very rigorous simulated engraving and cutting application environments, and they're holding up very, very well. So we're very happy with those. The encoders on the motors provide for extremely accurate counts, up to 16,000 counts per revolution. That's equal to over 20,000 counts per inch in the x-axis motion. I'll flip this door down. I want to point out the belts in here as well. In the x-axis, we've got double wide Kevlar reinforced belt, and in the y-axis, we use steel reinforced belts. Again, all of these things together mean that we've got a very fast system, but more importantly, we've got a system that's going to produce exceptionally good engraving and cutting quality. Along with the mechanical side is the electronic side. Our design engineers here at Epilog essentially started with a clean sheet design. Based on our 25 years of experience, we've put together an electronics package that drives this system that's state-of-the-art. We're really excited to couple the mechanical side, the electronic side, and this is the result. I want to focus our attention now on the control panel of the laser. We're going to spend a little bit of time talking about this, and then we're going to move over to the computer and talk about that a little bit as well. Like everything else with the Fusion laser system, the control panel has a completely new redesign as well. You'll see that we've got a 2-line display on the control panel. Fairly simple, but yet very powerful and can be very sophisticated. I'll scroll through these different functions on the display panel. By scrolling through, or how you scroll through is simply press the up and down arrows. When we have a job at the laser, I haven't sent one yet, we would see that job populated here. We can store a number of jobs at the laser and run any one of those jobs that we select at any given time. We'll do that in just a few minutes. The focus button allows you to raise and lower the table. We'll use the joystick control here to raise or to lower the table to accommodate a certain height material. The jog feature is a really nice feature as well. This allows our users to set a new home position, or maybe to mark or engrave or to cut an area or on an item that might be unusual in shape. So to jog the lens assembly, you simply go to the jog function and then use the joystick to drag it to wherever you'd like on that particular object. You'll see that red dot pointer. That would indicate where the laser beam is going to fire. That would indicate the new starting position for a particular job if you're setting a new home position through the jog function. Once you've done that job and want to go back to the original home position, simply hit the reset button and we go back to 0. The speed and power buttons on the control panel give you access to view the speed and the power that you're running. You can also change those parameters on the fly. This is a really handy feature if you're prototyping or trying to characterize a particular material and understand those parameters that you want to run with that. The config button is incredibly powerful. There's so much going on in here. Most of our customers would not use a lot of these features, but I'm going to scroll through some of these things just so you can get an idea of the type of functionality that we provide our customers with this system. Here we can hit the restore home table. This would restore back to a 0 level position. We can establish a new X and Y home positions here. The jog laser power, I'm going to show you this feature in a little bit. This is a really neat little feature that I think a lot of our customers are going to use. Quick table home, the serial number of the laser system, of course that's programmed in here at the factory before the system goes out the door. The IP address in the laser, we can print to our laser systems through a network connection. This is a really handy feature for those customers that maybe have one computer and multiple lasers and they want to print to those different lasers from that one computer. Or perhaps you've got multiple computers that you want to print to one particular laser. You just set up an IP address and direct the traffic to that location. Those are all applicable to the IP address. Here we've specified a CO2 laser. Again, we've built the Fusion to accommodate both CO2 or a fiber laser. And here we would specify that we are using a CO2 laser in this unit. We've got a vector grid installed in here, so I'm going to enable this to take a vector grid. So what I do here is I simply push down on the joystick and then select yes, and then hit go to capture that change. And I'll continue scrolling through. Air assist for raster or vector applications. These match values that you're seeing here are used to establish the correct lasing, left and right. Again, this is a factory set value that you should never have to worry about, but we do provide that for our customers to use in the field if they wanted to do that. So that's a quick tutorial on the display panel on the laser. Again, very simple, yet very powerful. Allows our customers to do a lot of different things with the laser right here at the laser system. Let's now go to the computer side. I want to show you graphic software, a couple graphic files that we've built. I'm going to show you the Fusion dashboard print driver, and then I'm going to show you a really exciting new feature that we've designed to go with the Fusion laser, and that's the Epilogue Control Center. All right, at the computer, we're using CorelDRAW. With any of our laser systems, you're able to use a variety of different software programs. Because the laser is such a powerful tool from a graphics perspective, we recommend a good graphics program like CorelDRAW. Adobe Illustrator is also popular. AutoCAD. For barcode applications, Bartender or Label Matrix is a popular choice. Regardless, with our systems, you can use a variety of different software programs. Our customers like that flexibility. They'd like to be able to choose the type of software that they can use with the system. We'll use CorelDRAW for this demonstration today. So I've built a graphic file in here, and you'll notice that I've got what we would describe as a raster engraving element, and then this line around the graphic is set up to be a cut line. So we're going to engrave that object, and then we're going to cut that out. And we're going to use wood to do that. Once I've got the graphic set up, I go to the dashboard print driver for the Fusion laser. So here I'm going to select the Fusion laser as one of my output devices. I'm going to go to the Preferences tab, and here is the print driver. What's really nice about the Fusion driver is that it works with both the CO2 and the fiber-based products. If I'm working with a CO2 laser, I'm going to select CO2. If I'm working with the fiber, I'm going to select the fiber. So here I'm going to select CO2 because we're working with wood with the CO2 laser system. I'm going to engrave this at 600 DPI. You can see that we can offer 75 DPI all the way up to 1200 DPI printing resolution. Most of the time you're going to be working at 400 or 600 DPI. For this example, we'll work at 600. Autofocus I'm going to select here, and I'm also going to select vector grid. Because we have that grid installed, we want to tell the laser that it is installed. This is a really neat feature here too. This is new with the Fusion. We can set autofocus based on the material thickness. So with a piece of wood that we're going to be working on, we know that it's 0.1 inches in thickness. And so I establish a 0.1 thickness value in here. I then go to the speed and the power for the raster. I make these settings that are appropriate for the given material that I'm going to work on. For the raster settings, I apply specific values. And then for the vector settings, again, the cutting, I'm going to apply different values that I know are going to work really well for this wood. I also want to show you the slow cutting and power compensation buttons here. These are new features for the Fusion as well. Slow cutting essentially cuts the speed value in half. So if you've got some real thick material that you want to cut through, you would select slow cutting, and that gives you a finer scale for those low end speed values. We won't need that for this example, but we're going to use the power compensation button. Power compensation is great for detailed or complex curves where you're going around curves. It provides for power compensation of the laser relative to the curve that it's making. It provides for a better cut around those curved surfaces. So we're going to use power compensation on. I've got everything else set here. I'm ready to print the job to the laser. So I click OK, and then print, and the job is transmitted to the laser. If I go back to the control panel on the laser, you'll see that we've got this job loaded up in the laser. The job is labeled Logo Wood. That's the file name that we've given this job at the laser. Whatever job you send over is going to show up here, whatever you've named it in the computer. So now we're ready to engrave. What I'd like to show you though, before we get started, is what I described as the Epilog Control Center. Again, this is a new feature for Epilog, specific to the fusion lasers. Wonderful tool here. In essence, the Control Center provides the same functionality at the computer that you have at the control panel on the laser itself. One of the neatest features here is this job time estimator. You can see that we've got one job sent to the laser. It's Logo Wood, the same job that we sent the first time. It shows here on the display panel. But the most important thing is it gives us an estimate of the time it's going to take to do that job. This is a wonderful feature. As an example, I did a test for one of my customers. He had a very large job, was wondering about how long it was going to take to do this job. Instead of running the job and waiting 3 hours for the job to finish, I simply set up the graphic, sent the job over, went to the control panel, and it gave me a really good approximation of how long it's going to take to do that job. Great feature here. I know our customers are going to find great utility in this one. In the control center, we have specified the laser type. This is really just informational type of stuff right here. Some of this stuff you can change, but again, a lot of this is just information about the parameters that you've set for a particular job. Here we're able to change the speed and the power. If we wanted to do that, we'll keep it back to those original parameters that we set. But again, the nice thing about the control center is it allows me to control those functions that normally are done at the laser. Once we've sent the job to the laser, normally we would go to the laser itself and press the go button to start that job. But with the ECC, we can simply push the start button here without pushing any buttons on the laser, and the job will start. So now we're engraving. It might be hard to see here, but there's a bit of smoke that's being generated during this engraving process, and it's removing from the laser system so quickly and so efficiently. Again, it's because of this front door design with that laminar airflow that we built into it. So we're just engraving one particular piece here. In most situations, our customers are going to load up the bed of the laser with as many pieces as they can and have the laser do the work while the operator's busy doing other things in the shop. This is what we describe as raster engraving, the left and right motion. The laser is pulsing as it's moving left and right. You'll notice it's very fast and incredibly good control over the laser pulsing, again, through the rigidity of the system, the mechanical design, and of course, the firmware. Once the raster portion is done, it'll start the vector cutting. When it's done, the laser will beep, indicating that the job is done. We'll go into the cabinet. Piece drops out. Very nice edge on there. Very nice engraving. With this next file, I want to show you the cutting speed and quality that we can achieve with the Fusion laser system. So I've got just a letter that we're going to cut. Again, this is set up as just a cut file. So I go back to the print driver, and in here I'll set all the parameters for this particular job. Again, CO2. Again, we want to use autofocus. The thickness on this is about the same, 1/10 of an inch, so I'll put that in there. I'll also indicate that the vector grid is installed. I'm going to set some speed and power values that I know are going to work really well for this. We're going to run this at 9 speed, 100 power, and a frequency value of 5,000. A high frequency value is more pulses per given distance, which is going to provide for a more flame polished edge. So once I've done that, I click OK, and I print that job to the laser. Again, back to the ECC, and I can control that job from this location as well. You'll notice here, this job is populated here. It's telling me that this is going to take approximately 17 seconds to do that job. I can run the job from here, but what I'm going to do is start this job from the control panel on the laser system, just so you can see how we can do that as well. So I'm just going to minimize that. The job is at the laser. Once I've verified that it's there, I close the door, and I hit the go button. We get a beep tone indicating the job is done. Part comes right out. Nice tight cut on that. While it's hard to see on the photograph or with the camera, that's an incredibly nice edge on there. Let's do one more job in the CO2 laser before we move on to the FiberMark Fusion. Bring up another file that we've already got set up in here. You'll notice that the image is mirrored. We're going to be working on a piece of mirrored glass, so we'll have to mirror image the actual graphic itself. So once I've got the graphic set up, I go into the dashboard print driver. I set the parameters for this job. Autofocus is selected. I want that to work. Vector grid is also selected. I know the material thickness on this particular piece is 0.123, so I'll establish that. These speed and power settings look good. I'm going to run this at 48 speed and 100 power. I'm going to click OK, and then print. The job then goes to the laser. Remember that it's also available for us to view in the control center. Here's our job, glass.cdr, and it's telling that this job is going to take about 32 seconds to run. Again, we've got all this information in here specific to this particular job. We can change a lot of these parameters at the ECC as well. Once I've got the material placed in, I close the door, and again, press the start button on the control panel, or rather the ECC. I don't need to press the go button at the laser itself. It might have been hard to notice that, but there was a slight change in the table height there. Because this is a little bit thicker material than the wood and the acrylic that we were using, the table actually lowered just a little bit. You'll notice in the ECC that while the job is running, the engraver status is red. Also, the job indicator is red. When the job is done, this status will turn to a green, indicating that the job is completed. We'll come over to the laser now, pull the mirror out, and of course we've engraved on the back side, so we'll flip that around, and we've got a really nice engraving on that glass material. Now we've done some standard engraving and cutting applications with the Fusion laser through the control center at the computer. Let's do something kind of unique with the laser system. We're going to establish a new home position. We can do that through the joystick control using the jog function at the laser, or we can go to the control tab here at the Epilog Control Center. I'm going to click on this, drag and drop it, and I'm going to move that lens assembly right over to the corner, or close to the corner of that piece of acrylic that we have in there. Now I'm going to set this as my new home position. Once I've done with that, I go back to the job, I verify that I'm going to do the cut sample. I'm going to close the lid, and then press the go button at the control center. Again, I'm controlling the laser from the computer. This is a great feature for one-off marking or engraving cutting applications, or if you have an unusual shaped item. Really nice to be able to change the home position instead of indexing from the upper left corner all the time. There's our new cut piece, performed at a different location than the standard 0-0 position in the upper left corner. The last feature I want to show you on the CO2 Fusion laser is a really neat feature that we built into this system. If you've got some scrap material, you've got a bunch of holes in it, engraving on it, and you want to find a space that you can use later, we're going to trim this off. So we, at the control panel, we'll go to the jog function, and we'll use the joystick to bring the lens assembly wherever we want on the table. I'm going to park it right about there, and we're going to trim this material right across there to give us a new clean sheet to work with. So once we've got the location set, we'll close the lid. On the control panel of the laser, I'll press the Laze button, and then with the joystick, I'll move the lens assembly across the material. It's actually cutting through that acrylic right now. I'll stop it there, open the lid, and we've got a nice trim piece, another piece of material that we can use later. Our CO2 laser systems find utility in a wide variety of markets: signage, woodworking, architectural modeling, plastics and acrylics fabricating, awards and crafts, industrial marking and cutting applications, promotional products, and more. The wavelength of light from a CO2 is incredibly versatile. It works with wood, plastics, acrylics, glass, textiles, cork, leather, rubber. Many materials work really well with a CO2 wavelength of light. Our customers are so creative. They do such great projects. We're really excited to get the Fusion in their hands and see what they can do. Let's now turn our attention to the Epilog FiberMark Fusion laser system. Much like the CO2 system, it's got a 32-inch by 20-inch work area. It also has a 12-inch Z capacity. This is wonderful for our customers that have very large parts that they want to mark on. We have a lot of interest in the industry for a laser system that would accommodate larger parts. We're really happy to deliver this laser now. The wavelength of light generated from a fiber laser is different than a CO2. The fiber laser is typically used for metal and engineered plastic marking applications. Common materials include stainless steel, titanium, aluminum, Inconel, black oxide, and also engineered plastics are very common for use with a fiber laser. Most of the companies that are buying the FiberMark are doing direct metal marking on the variety of materials that we've talked about, also the plastic marking applications. Those customers that are buying and using the FiberMark laser typically are in the medical device industry, automotive industry, defense or aerospace industry, or general CNC shops that are manufacturing a metal component and want to put a barcode, a serial number, or some sort of branded logo on their parts. With the laser system, the FiberMark that is, we can create a variety of different types of marks on different types of metals. Depending on the type of metal, we can produce different colors, we can do an etch, we can ablate metal, we can do more of an annealed or a black oxide type of marking on the metal. We can even do polishing on different types of metals. The types of marks that we can achieve will in large part depend on the type of metal that we're working with. Let's set up a job now with the FiberMark, run a few samples for you and show you how we operate the FiberMark. Again, it's much like the CO2, but I want to show you some marking on some metal. So let's go to the computer now and we'll set up a job and run it. All right, so we're ready to run a job in the FiberMark Fusion laser system. I've got a graphic set up in the computer here. Again, I'm using CorelDRAW. Our customers might use a variety of different software, but for this demonstration, again, we'll use CorelDRAW. I'm going to select this top graphic. I'm going to go into the dashboard print driver for the Fusion laser. I'm going to select selection here, so I just want to engrave and mark that one particular item. Here, I'm going to select the fiber laser as opposed to CO2. This gives me additional control in the driver that I don't have in the CO2 laser. I'm going to do a raster job here. I know that for this particular speed or this particular material, I need to run at a certain speed and power, so I can set that here in the raster portion. I'm going to set the speed a little bit low, the power high, and I'm going to establish the frequency low as well. Once I've done that, again, I just click OK and then print. The job is then sent over to the laser. Let's go back into the Epilog Control Center and take a look at how long we think that job is going to take. So we'll go to the Jobs tab here. The Control Center is telling me that that job is going to take approximately 1 minute, 21 seconds to complete. Again, a really nice feature for estimating how long jobs might take. Imagine if you had a table full of parts, if you're trying to estimate a job, how long it's going to take to do that. You can simulate that on the computer, send the job over to the laser, and without even turning the laser on, know how long that job is going to take to do. Great for estimating or predicting how long a job is going to take and for costing. But once we're done here, we can simply click on the Go button. But actually before that, of course, I got to close the lid on the laser system. I'm going to do that now. Close the lid, and we're ready to run this job. Again, I can press the go button on the control panel of the laser, or I can do this right at the Epilog Control Center. So I'll press play here, and the laser will start marking. This is a typical etch type of mark that a lot of our customers do. We're running this fairly slow because we want to get a nice deep etch into this stainless steel sample that we're working with. With the beep tone, we know the job is done. We'll open up the door on the laser system. There's always a little dust that comes off of material when you're marking it. There's a nice deep etch into that stainless steel. Now we're going to demonstrate a different type of mark that you can achieve on stainless steel. We've already sent a job over to the laser system using different laser parameters. With this one, we're running higher speed, a little bit more power to create sort of a polish type of mark on the stainless steel. Again, you can get these kinds of marks on steel, different types of marks, and depending on the metal, you can get a variety of different colors to come off. So we'll run this laser here. You'll notice that this laser is moving a lot more quickly. Again, this is going to be more of a whitish, polished type of mark. With stainless steel, we find that we can get a black mark, a dark brown type of mark, a whitish kind of mark. We can achieve mirroring, and all of this is done by changing laser parameters, speed, power, frequency, and focus values. Again, every type of metal will react a little bit differently with this wavelength of light. At our applications lab here in Epilog Laser, we're happy to help our customers to define the correct settings for their particular materials for a given wattage laser system. This job is complete. We'll open the laser, and you'll find this to be much lighter in color. As we talked about previously, the FiberMark Fusion laser system produces a wavelength of light that's great for a wide variety of metals, but it also works really well with engineered plastic material. We've got a piece of plastic in here. We're going to run this job. We're going to run the same graphic file. Of course, we're using different speed and power and frequency values for this particular material. So we've got the material in. Again, we're just using a small area to demonstrate here. Most of our customers are going to load up the entire bed of the laser and have the laser mark all of the parts at one time. You'll see that this plastic engraving is a much higher speed marking application. Same logo, same graphic. You can see that we're moving pretty quickly here and producing a really nice mark on that plastic. Nice dark mark, nice contrast on the white. Laser engraving and cutting technology is more versatile, user-friendly, and accessible than ever. Regardless of industry, today's enterprise can perform a variety of laser applications in-house, from creating custom signage, to part identification and marking, to branding of promotional items. Epilog's new Fusion Laser series features the high-quality systems that companies need to meet the demand of those applications, quickly, easily, and cost-effectively. We really appreciate you being with us today. Give us a call, look us up online at epiloglaser.com. We'd love to talk to you more about your applications and see how our products can meet your needs. Thank you.